Yes. Yes. Okay. Cool. Okay. So welcome everyone. Thanks for the patience. And I do or skip my standard introduction. I think all of you know that, a couple of slides already. And yeah, welcome everyone to today's talk in the Design++ speaker series. It's my special pleasure to welcome Professor Matthias Del Campo, who joined us from the US today. And yeah, as I said before, I skip all the intro today, as you can find all the information in the video later on the YouTube channel. And with that, I would already hand over, and the stage is yours. Thanks for coming.
Thank you very much. Again, my sincere apologies for the delay, but let's go into the middle of things right away. So just briefly to introduce myself, Matthias Del Campo. I'm an associate professor of architecture at Taubman College of Architecture and Urban Planning at the University of Michigan, and director of the ARI laboratory, the Laboratory for Architecture and Artificial Intelligence, which is a collaboration between architecture, computer science, robotics, and data science. So we have there students from all of these fields working together on a variety of projects. So the lecture is called Neural Architecture, Design, and Artificial Intelligence, and is the basis for this lecture is a book that I recently published called Neural Architecture, which is sort of like a summary of a variety of ideas, concepts, projects that we have been doing primarily at SPAN, at my architecture practice throughout the last couple of years. It evolves from a series of papers about a variety of topics in AI and architecture. So the main idea behind this was not so much to create sort of like a tutorial or technical manual, but rather interrogate the underlying theoretical discursive aspects that come along when you work with AI, and some of the influences that come from other fields like neural art, who have been working with this a little bit longer than architects, and what they have learned by doing so. It is a collection also of a couple of projects that were done in the time, among them, for example, the robot garden, which I think is most likely, I'm not going to claim that because I'm not entirely sure, but most likely the first project that was entirely designed using AI from scratch. And then it interrogates also what it means when you as a discipline are able to interrogate like this vast depository of human culture through a variety of tool sets, because it's able for us to harness big data through these tools, and how this comes back into topics like style, or what estrangement means in this new ecology of design, what post-human design could mean. And when I say post-human, I don't say after humans or mean after humans, but rather a field of design that is not purely top-down from human downwards, but where several players on the same field interplaying and discussing and interseminating each other, inspiring each other. Yeah, so let's go further ahead. So what do I mean by neural architecture? Neural architecture is basically the field of architecture that interrogates a variety of algorithms and mathematical formulae, which allow to interrogate the vast repository of human culture, and then is able to put them together into projects that are provocative, inspiring, unnerving sometimes. But most importantly, what they do is they basically allow us to interrogate areas in the data sets that exist of, for example, architecture, which were not visible to us before, because what a variety of neural networks do is basically to show us the latent space between known data points. And by looking into these areas, we can find things that might inspire us as architects to respond with a specific idea of architectural design. So the first question in general is, why to use AI at all? I mean, this is, I think, the most important question at the very beginning of any one of these lectures. And what I mean, this is not my quote. I have actually figured out from who this is. I heard it several times and never knew who did it, but it's better to teach machines how to learn instead of how to do things. Yeah, it's better to teach machines how to learn instead of how to do things. So what is meant by that? You might have seen videos like this ones already before, like the way how cars were built until basically the late 60s. when you had like a set of experts who knew, for example, exactly what it means to weld pieces of cars together. They applied their expertise over and over again in all these factories. And these are all, one is, for example, from Volkswagen. The other one is from the Ford Dearborn assembly line. So you have these people all working together, applying the expertise that they learned over their careers as welders or painters in a factory. Now, 1967 was the first introduction of an assembly line with robots, or let's say the first industrial robot was applied on an assembly line in a factory of General Motors in New Jersey. And the robot was the Unimate one. And since then, it of course exploded. We have seen all this development of using robots, industrial robots, to assemble cars. But what you have to do, and every one of you has worked with a robot, you know there's the pendant that allows you to train a robot, right? You literally train where to go, what to do. Yeah. So you very specifically include information in the process, and you teach it exactly which point in space is it that you have to go to weld those pieces together of one specific car model, right? That's the thing, because then if another model comes along, you have to retrain everything, yeah, which is of course very costly and time consuming. So, but what happened in the time, which is quite interesting, is that the car industry collected millions and millions of data points about which one are good welding points in space to weld a car. So you can take those points and train a robot, not to understand specific models and specific points to weld together, but what it means to weld, what it means to weld well. And by doing so, you can basically teach a robot, so it learns, yeah, what those points in space are. The advantage of that is, of course, that using machine vision, you can get this car carrosserie come along, yeah, and the robot will automatically know where it should weld those pieces together. And the next car that comes along can be a completely different model. It doesn't matter, yeah, because it learned what it means to weld. So to the completely different area, which is less technical, the rise of neural art. So you might have seen this painting already before, the portrait of Bertrand de Bellamy by the Paris-based art group Obvious, which became notoriously famous in 2018 because it sold for almost $500,000 at Christie's, and it was presumably the first artwork done by AI. Whether this is true, it's probably up to art historians in the future to figure out. But the interesting part for me here is, apart from it being a very attractive piece of art, is questions like agency, authorship, yeah? Who is the author of this piece of art here? Is it the art collective who came up with the idea to use a neural network? Is it the programmer of the neural network? Yeah, because otherwise this wouldn't exist. Or is it the hundreds or maybe thousands of artists in the data set used to create this painting? So it becomes blurred. 2018 was also the year where I think neural art really became more visible with artworks by artists like Mario Klingemann, Sophia Crespo, Yacht, Dadabots, Holly Herndon, which you see here, a video, which by the way is also a collaboration between a neural artist and a musician. So musicians, of course, also use neural networks to make music. So neural art is not restricted to the visual arts. It also includes music. It includes literature. Yeah. Literature, by the way, I think was one of the first users of these sort of methods. They started thinking about automatic writing already in the 60s. This is, for example, a collaboration between Mario Klingemann and Yacht from Los Angeles, where two things collide: the visual arts in neural art and the music made by neural networks. So there's like a whole cultural phenomenon, in my opinion, currently emerging in our world that basically discusses exactly what I described before as a post-human universe in terms of the arts. Yeah. And around the same time, we started to experiment also with neural StyleGAN, StyleGAN 2, and various of these methods. This is, for example, the result of a data set we made of Gothic architecture, and then trying to figure out like what's going on in the latent space of these data points. Yeah, it was a very, by the way, creating the data set was quite fun because I used scraping. Any one of you is familiar with scraping? Yeah. So I scraped the internet for images, and I actually scraped for goth images. And yeah, you can imagine that the results were a little bit iffy. Yeah, but it also showed me how much manual work is necessary to get a good data set. But what does it mean for the architects when we are now involved in this whole new ecology of design, which is quite interesting to ponder like what our role will be also in the future of this ecology. Now, these are some early experiments we did on trying to generate plans with neural networks. And this, of course, immediately, it was very provocative to us because on the one side, we as humans can interpret the results of these processes as something that resembles sections or plans. And when I first saw these results, I was immediately, oh, great, I can train it to make automatic plans and sections. Amazing, fantastic. And then I started to look closer into them and started to understand that it does actually not understand what's happening in a plan or a section. So the semantic information to understand that this is a classroom, this is a staircase, this is an elevator is not there in the data set. Thus, it cannot understand what it's actually doing. It can imitate the imagery of a plan or a section, but sometimes this might be even enough to inspire us to do something interesting out of them, because that's, I think, one of the major achievements of this technology. So I already started at the beginning to talk about estrangement and defamiliarization as categories of interrogation in this idea of design. That is based on the works, for example, of Victor Schlovsky, Bert Brecht, Sigmund Freud, and others. So what is estrangement, or Ostranénie, as Victor Schlovsky described it in his paper in 1917? I forgot right now the name of the paper, but it already came out in 1917. So basically, the idea behind it is that you take everyday objects, and put them in some strange context, or there's enough abstraction into them to evoke attention. And attention in all this whole neural network processes is a very interesting category. There is, for example, also something like attentional generative adversarial networks. I'm going to talk about this in a second. But more importantly, culturally speaking, the estrangement or defamiliarization is something that where things are familiar to us, but at the same time strange enough to be of interest. So in this case, for example, this is a latent walk through a brutalism data set, I think, and on the right side you see the same latent walk, but including Picasso. That's a simple exercise, right? But it's still, once you know it is Picasso, by the way, you start to see it if you didn't see it before. So estrangement was already present in concepts described by Hegel, Karl Marx, Victor Schlovsky, and Bert Brecht. As I mentioned before, Brecht, for example, used this method in his theater plays intentionally to make the audience aware about the artificiality of the play. So he didn't want to make an immersive, realistic representation of the play, but rather wanted people to focus on the content that is actually produced by the play. So this is also, of course, in terms of architecture, quite interesting that it allows you to include abstraction into your designs. And of course, you cannot talk about estrangement and these sort of things without mentioning at least Sigmund Freud. Sigmund Freud wrote a paper called Das Unheimliche, the Uncanny, in which he described also the effect that things that appear uncanny to us still have to remain enough familiarity to be able to be provoked by that. So something that is completely alien is very difficult for us to perceive, but something that is somehow familiar, but has a twist to it, so to speak, is something we will look at and be inspired or provoked or captured. So it evokes, of course, an emotional response. And I think this is an interesting process also for architecture. Like, what does it mean when architecture evokes an emotional response? And these are the things that I try to do with all these things that I described before. So this is a good example for estrangement, in that you have, it's obviously a villa, it's obviously on a cliff or on the mountains. We recognize enough familiar architectural features here, like Fensterbänder and very particular orthogonal shapes. So we can read this as a house, despite the fact that, for example, the way how it touches the ground is completely unclear. This is the AI made this completely up, like how it touches the ground, because it had no information about that. Same also with the condition of the roof. Like is this natural rock? Is this made of concrete, which is very sloppy? Is this badly done, or is it intentionally done like that? Yeah. So all the things that go through your mind while you're looking at this image are exactly these aspects of estrangement that provoke your mind to look deeper into this image. Graham Harman, I'm not the biggest fan of Graham Harman, I have to say, but he wrote one book which I really liked a lot. It's called Lovecraft and Philosophy. This is one where he describes a similar effect also in literature with Lovecraft, where he, for example, describes he meets his cousin in a pub and he looks very familiar, he knows him and so on, but the cousin starts speaking and his voice changed to the monstrous. So it's a familiar figure, but it has a strange voice, thus it creates this sort of uncanny effect. I've been saying that this is probably the first 21st century design method, and I'm going to try to explain why. If you think about computational design methods of the last 20, 22 years, all of those were already invented in the 20th century, late 20th century, parametricism, agent-based modeling, what else comes to mind? Yeah, I have like a bunch. I cannot see my lecture notes, so I'm not entirely sure about my whole list that I had there, but the ones that come really to mind are agent-based modeling and parametricism. Like both of those were already present in the late 90s. But what we see currently now happening with neural networks and with AI was not even possible 10 years ago. They were like this, the algorithms were not there, the technology was not there. So a lot of those things were missing. And I'm going to give you a couple of examples. So one being the robot garden. So the robot garden was a commission by the University of Michigan, by the robotics department. They actually created, they built a new building on campus, and they wanted to have next to the building a testing ground for their robots. So the director of robotics came to us. We were working at the time also with a PhD student from robotics to learn about machine vision techniques. And he said, like, well, you guys have been working on some design methods that include machine vision and those things that we use in the department. And we would be super interested if you could actually design this robot garden with these methodologies. The basic, what the robot garden is there for is a testing ground for the robots with legs. This is one of the specialties of the University of Michigan. And there were some requirements. The requirements were, it has to have a variety of different ground conditions. It has to have stairs, and those stairs have to vary. Because what they're basically training or testing on this site is the so-called last 100 step problem, which is if you want to have robots that make deliveries to your house, the most difficult part for a robot is from the delivery van to the house door. There's last 100 steps, because the grounds change. You have gravel, you have sand, well, sand maybe not so much, but concrete, you have asphalt, you have boards, wood boards. And most of the time, you also have steps. Specifically, if you think in America about one family housing projects, they almost always have steps that lead to the door. So they had to test this. And so they gave us these parameters. And Alexandra Carlson, who we were working with at the time, together with us, developed a variety of, so we combined a variety of methods in this one. So it's not just one method. It includes 2D to 2D style transferring, it includes deep dreaming, and it includes 2D to 3D style transferring. So we applied all these methods in this project. So the ground conditions with the different, gravel, sand, rocks, and so on, that was developed using a data set of a couple of thousands of satellite images. And then we basically created a StyleGAN 2 through that, to get to some images at the end, and then use those images to define the different materials. And then the steps were included using deep dreaming. So we created a data set of fountains, steps, I think columns. I don't know why we put the columns in there, but they still were there in the data set. And that actually allowed us to create the steps or deep dream those steps on the side. I like this video a lot because it actually, I've had other lectures where I showed some random machine vision video of a car going along a street, but I was happy that the guy said, or the people at Michigan Robotics provided me with this video, which basically shows how a robot sees the site. And this is something I've always been fascinated with, like how different the perception of the world is from machines to us, despite the fact that, of course, we invented it and we defined it. But it's still very, very compelling. Like, for example, where there are shadows, it doesn't see what's behind it. It cannot construct what's going to happen behind a column. Yeah. we humans have like this ability to somehow predict that. Yeah, machines don't have that yet. So wherever the vision is blocked, they don't see anything. This is just a brief part of the satellite image data set. Some of the tests we did with deep dreaming. So it needed a lot of attempts to get to something that was workable. It's nothing that works the first time around, but it was really worth trying and figuring out things, or even finding mistakes that were really interesting. For example, in the lower row here, we got a lot of features that were vertical, although we were trying to do a fountain, a flat fountain. Yeah. And then we figured out that the data set had so many fountains with sprouts that it learned that feature, right? So it thought it's part of the architecture. And this is one of my favorite results because I think this one represents really well how machines really perceive architecture or would like architecture to be. Yeah. I mean, this is super speculative and a little bit romanticized, but I think it's fun nonetheless. Text-to-image generation. Even if John Oliver talks about Midjourney, it means that it has become really the middle of mainstream. So AI has arrived in mainstream. Like, let me put it this way: AI generating art or images with AI has arrived in the mainstream. And I like this quote in the frame of this thinking: "The limits of my language mean the limits of my world." Although this is also not entirely true anymore, because you can use in Midjourney images now as prompts and not just text. But just as a precursor of what has happened this year, this is a project we did in 2020 using attentional generative adversarial networks that allows us to write text and then get images out of them. This is different than the diffusion models we see today, but it basically did the same thing on a far lower resolution, far worse, but regardless, it was interesting to us to test it and to try it. And what we did was basically take one sentence from the program that was asked on that side and then add like a surrealist twist to it. So for example, the gym has 2,000 square meters, has 2 basketball courts and changing rooms, and is standing on yellow canary legs. Yeah. And then once you do that, you get this really strange, colorful imagery out of it. And then we really used a sort of a simple grasshopper definition to extrude volumes out of that, yeah, to generate the buildings. It was a learning process for us. It was not perfect, yeah, but as Alberto already said, nothing new is perfect. But it helped us in really generating this project quite quickly. One thing we learned doing this was the problem at the time, is that it was not possible to create the interior and exterior at the same time. Yeah, so either the exterior or the interior, but it did not understand, or we couldn't concatenate the processes to really create everything at once. So a lot of manual labor was involved in creating what's going on in the interiors, how is the levels, do we really fulfill all the square meters for the competition, is it all organized correctly? We intentionally created the interiors totally pragmatic, like super simple, no fancy stuff inside, very, very simple. And then early this year, I stumbled upon disco diffusion. I like to look into boards and chat rooms of media artists, because those guys are always the first ones to find this stuff. And so I started using disco diffusion. And one thing that I noticed very quickly about all these diffusion models is that they have something very much in common in how we as architects work, which is working through variations. Yeah. Everyone knows this process. Like a conventional architect takes a pen, starts to draw a sketch of a plan, and then there's another sketch and another sketch, and iteratively works on solving problems in that plan, right? This is an example of volume models done at the Atelier Hans Hollein in 2004. Same problem, like interrogating the volumetric possibilities for doing this tower. This tower was ultimately built. It's the Saturn Tower in Vienna. But here we have like a thing about how many? 28 models, yeah, that basically interrogate variations of volumetric possibilities. What Midjourney and diffusion models do is they amplify that. So I did a little math a while ago, and I figured out that from late April to late August this year, I generated 75,000 images in Midjourney. And I'm not even the power user. Like there's people who've done much more than that. But what I think is interesting, that maybe architects feel so attracted to it because of the possibility to create variations and work through variations very quickly. So when you use Midjourney, you put in a prompt, it will give you four versions, like four possibilities to either expand them into a larger image or make variations of that. And I think that's so profoundly architectural that's why I think architects are so attracted to it. Okay, very quickly, like how does this happen? Where does diffusion models come from? In 2015, there were enough annotated images in a data set that it was possible to create something called automated image captioning. And what this does is basically, like, for example, we have images that are annotated with this is a dog, this is a person, this is a car, this is a tree. And because there was enough of those, it was possible to do this here. Basically, create an algorithm that was able to automatically label or create a caption of an image. So it sees this here and says people walking on a bridge. Yeah. Now somebody came up with the idea, what happens if you turn this around? Like we take the sentence and let the machine generate the image. Yeah. And this was Elman Mansinov and others at the Amazon Web Services. They also created a paper right away called Generating Images from Captions with Attention. And that's basically the idea they had. So yes, this is also a nice one. This is from the paper that they published. This was their first attempts to do that. And like, look at that. A stop sign is flying in blue skies. I mean, with a lot of imagination, you might be able to see that. But it's the problem being that the resolution was, I think, 72 by 72 pixels or something. I mean, it's really hard to do anything that looks sharp with that tiny resolution. But the resolution really came up in the last years. What it basically does is it takes an image in the data set and introduces noise iteratively until it's completely just a random noise image. And that it does this all the time, like in one direction, and then it turns it around and organizes the pixel according to your prompt. So it starts always with a random noise image, and then it generates an image, which, by the way, also leads to the phenomenon that when you type in the same prompt twice, it will always generate another image. Every time it will do another image because the random noise at the beginning is different. But it also can do things like this. This is where things get a little bit iffy, in my opinion. So if you prompt something like Mies van der Rohe building, in the meantime, you get already pretty good results out of it. Yeah. And this, in my opinion, opens all the doors for lazy architects, yeah, who are going to start imitating stuff up and down, left and right, because it's so easy to do it now. Yeah. So be prepared to see a lot of copies around. I mean, people copy anyways. We know that. Yeah, they copy anyways. It's just a tool that makes it easier. Yeah. But there's other things you can do. Like, for example, also a comparison here between version 2 and version 4 of Midjourney. The prompt is a section drawing through an opera house. And you get things like this. Of course, this is not a section through an opera house. It does not work. A lot of things are missing. Yeah. But as I mentioned before, it can be sort of like a sketching inspirational tool that allows you to think like, wait, I could use that. That's interesting. Yeah. But also it shows here that the development of Midjourney has been quite interesting because this is version 2, which came out, I think, in May or June this year. Yeah. No, earlier April, which was pretty rough. You know, I mean, the images were not perfect. There was a lot of errors in them, but the errors, what makes it interesting, in my opinion, because if you use the same prompt today with version 4, this is last week, you get this, which is a sort of an historicized romantic idea of the opera house. It tries to emulate something that looks very realistic, yeah, but at the same time, there's a little bit there, which is a little bit strange and interesting to me. But honestly, the older version was a little bit more aggressive in terms of creating things where the AI did not know, or where the neural network, or well, it's actually a diffusion model, did not know what to do. It just made things up. And that made things up was really interesting because that's where things get interesting. Again, comparison between Midjourney version 2 and version 4. Prompt, the most beautiful house in the world. Like, what would an AI think is the most beautiful house in the world? Okay. And now the same thing with the newest version of Midjourney, the most beautiful house in the world. And I did this last week. So if AI thinks that this is the most beautiful house in the world, I'm not worried about architecture. Okay. The same sentence, same seed. Yes. Yeah. So, so these were the things that I did very early on using Midjourney, which I thought is really fascinating. Creating these sort of really bizarre, strange things like a hairy villa, the QPC house made of Kobe beef. New Piramesi etchings is rather not so. I mean, yeah, okay. A scaly house, a house made of feathers, a brutalist villa in the Alps. I recently heard from a friend that the first time he saw that house of feathers is when he started to get a little bit more interested in AI, because he thought, okay, it's doing something that is really different. Yeah. Or tectonic facade studies, which became very, very popular very quickly. Again, iterations, but also like really getting into high detailed, very, very crisp imagery that can definitely, I mean, you could take that, and if you want, you can start trying to 3D model it and even building this. I don't think this is actually impossible to build. On the contrary, we might have a couple of joints somewhere, but other than that, I think it's totally doable. Yeah, I'm gonna just jump over those here. We're running out of time, so I would rather go to here, where it's the development of the sectional qualities. And I think this is getting really exciting now, where things are happening that are profoundly different, usable in some way. Still, they make no sense. Yeah, the intelligence of understanding which room is what or what is what, it still does not understand that. Yeah, but it doesn't matter. There are humans that can interpret it and say like, okay, I think this is this or that. And then how do you do these things in 3D, right? I mean, this is always the big question here. Like, how do you really generate those things in 3D? I mean, first of all, I want to say that I wanted to show this because every single time I do a lecture, it's the first question I get. Like, how do we do this in 3D now? Yeah. And I like to say that the ability of humans to imagine a three-dimensional space, fold it onto a two-dimensional surface as a plane, section, or elevation, and then being able to unfold that again into 3D, into something that is large scale, is one of the biggest achievements that we did as a discipline. So the Albertian paradigm is probably the most incredible intellectual achievement we ever had. So I'm proud of that. And I think we can use that. If I get 2D images from a neural network, I'm okay with that. However, let's speculate how to do it in 3D. So this example here, we did a training set based on brutalist buildings. Then we did a latent walk. You saw already some of those images before. As I mentioned before, this allows us to look between known data points and interrogate this area for unseen imagery, and then use that, for example, for further development in a project. So what we did was creating those latent walks, then selecting a series of images from that latent walk and create a pixel projection based on it. And the pixel projection basically takes a high contrast image and is able to generate a model between these two or sometimes three directions of projection. So this project, by the way, is a shopping/office building in Vienna at the Marie-Hilfer-Straße. There's already a building there. It's it's in okay shape. It was remodeled recently, but it's coming to the end of its life. And the result basically is this strange block of concrete and glass that is standing there on the street with a very specific surface quality. So we used also imagery from the latent walk as to create the surfaces. But on the other hand, it still needs a lot of manual work to get it to a full project. So it gave us the floor slabs, it gave us the skin of it, but we had to put a lot of work into understanding where's the glazing, where really the floors, the staircases, elevators, like all of that had to be modeled then on top of it. Here you see that separation. All these slabs and stairs that you see there were modeled then in an after the 3D model was done by the pixel projection. But for us, this is an interesting method in trying to continue, trying to get whatever is getting provided by a neural network, or maybe also a diffusion model, into a 3D model. Okay, and then this is the newest one we did. This was an interesting commission. It's a neuroscientist, an Austrian, oh, sorry, not neuroscientist, a neurologist, yeah, who saw that we're using methods that are basically based on neuroscience in order to create design. And he was really interested in that, saying like he would like to have a house that somehow is connected to his discipline. But he had one condition. It had to be a mid-century modern house. That was his condition. So we created a data set of a ton of facades of mid-century buildings, again, creating a latent walk through those. And then, again, using pixel projection to create the model. Now, what happened in this case, which I thought was really interesting, is that it also, like the previous project, it provided us also with the interior. But this time, we almost didn't have to change anything. It was very complete. There was everything there that we needed. It, of course, needed a little bit of human interpretation, yeah, but we got it to work. And like, for example, nothing on that ceiling was modeled by us. This is all part of the result that we got out of the process. And we used it as we got it out from the process. We didn't change anything on that roof, apart from, yeah, some structural things that need to be done. But other than that, there's very little done on this. All the blocks, all those benches, I don't know exactly why these results came out like this, but they were extremely useful. And we basically did have to change just very little on it. We still have some floating beds and things like that, but we're going to figure it out how to make it work. Maybe some tiny steel legs or something, not sure. Okay, so much for the projects. Just very quickly, so I'm also the founder of the Neural Architecture Group, together with Daniel Borlochan, Immanuel Koh, and Sandra Manninger. We meet more or less regularly to discuss things that surround AI and architecture. There's the website aiarchitects.org, where you can find like a variety of different positions. I think we have like about 10 or 12 architects in there now. We're actually getting more and more people involved. I would like to build this more up as a community of people interested in design and architecture and AI, but also interrogating, of course, like it's not only the technical abilities, not only its abilities to optimize or predict, but also what it means culturally. And then the ARI laboratory that I mentioned at the beginning, which sort of deals more with the pragmatic parts of AI and architecture. Like we're currently building 2 data sets, one about apartment floor plans, one about one family housing projects. The floor plans are in 2D. They're labeled from people all over the world. They're plans from all over the world. We're trying to avoid Western bias in the data set, just to approach a more ethical approach to making data sets. Same with the one family housing projects. There are people involved from all over the world. This is one of the most important aspects actually of what we need to do as architects now, is to understand how we can use this technology ethically within our own community. There's a YouTube channel. I guess I'm gonna also copy paste your video into that one. So that collects lectures and so on. And this is the book Neural Architecture, Design and Artificial Intelligence. This is shameless self-promotion now. Yeah, sorry for that. Machine Hallucinations that I had the pleasure to do together with Neil Leach. I'm going to jump over this and say thank you very much. Yeah, almost there.